Position versus time graph 2. Let's consider an example where a body is moving with a uniform velocity in negative x direction. So as you can see, I have a graph where x-axis represents the time in hours and y-axis represents the position of the body in kilometer. Now what I'm going to do, I'm going to consider a straight line where the body is moving in that direction or along that line. So the graph is like this. In order to find the velocity of the body, what I'm going to do, I'm going to consider a point. So this is the point where the position of the body is x1 at time t1. So basically, this is the initial position of the body at time t1. Now let's consider the final position of the body, which is x2 at this point, and the time is t2. So basically I have initial and the final position of the body as well as initial and final time. In order to find the velocity of the body, what I need to do, I need to consider a point over here, and then I need to join all these points to make a right triangle. So if I do that, I will get a triangle something like this, where the length along this side of the triangle represents the change in position, which is basically delta x, and that is equal to x2 minus x1. And this is the side of the triangle that represents the change in position. In the same way, we need to find the change in time, and the change in time is from t1 to t2. So we will write delta t is equal to t2 minus t1, and this side of the triangle represents the change in time. Now we know that the slope of the line is basically the average velocity, or we can say the velocity of the body. So we need to find the slope. In order to find the slope, what we need to do, we need to find the change in position and change in time. So let's first find the change in position, which is delta x is equal to x2 minus x1, and my x1 is 100 and my x2 is 50. So basically the position is changing from 100 kilometer to 50 kilometer. Now let's substitute that value over here, and if I do that, I will write delta x is equal to 50 minus 100, and we know that 50 minus 100 is negative 50 kilometer. So the change in position is negative 50 kilometer. Now let's find the change in time, which is delta t is equal to t2 minus t1. My t1 is 2 hours and my t2 is 3 hours. So change in position is delta t is equal to 3 minus 2, which is equal to 1 hour. So delta t is equal to 1 hour. Now let's find the slope, which is basically the velocity or the average velocity of the body, and the slope is equal to delta x over delta t, and my delta x is negative 50 kilometer and delta t is 1 hour. So we will write that is equal to negative 50 kilometer over 1 hour equal to negative 50 kilometer per hour. And this is the velocity of the body moving with a uniform velocity in negative x direction. And this is how we will read or solve a problem based on position versus time graph.